All right. So how's your life going? Oh, that's good. So, I once again am reticent to get into any sort of new material, given where everyone is on this project. Anyone actually turn it in? All right, good job. Have you looked at Project 4 yet? Okay, maybe I'll talk about that on Thursday. I've been kind of re-architecting a lot of stuff that's used later, and so as recently as probably yesterday, I pushed some updates to Project 4, but it should be pretty rock solid at this point. You got any, what about, oh, I guess let me talk a little bit about the header files and the includes. There have been several people who've gotten tangled up with the includes. So there are a couple strategies to consider when you are including a header file. Obviously, you only want to include a file. Let me focus on the header files where you have includes in the header files. You only want to include it if there is information in that header file that you can't do without. So this is constant.h. It is including expression.h, and the reason it is, let's see if we can find a good reason. Maybe there isn't a good reason. I think this might be an example. Oh yeah. It's needed because you need to know. That's why you need to know the entire class structure in order to inherit from it. So that's legitimate. I need to find what's a better example. This one might actually, let me do. All right. So, oh. Hang on. Right. Okay. So here's a good example where I didn't follow the advice I'm about to impart on you. My first inclination here, and your first inclination will be that this class declaration uses symbol. So let me highlight where it's used. And so it's used in 3 places, on lines 9 and 10 and on line 18, and therefore that's the motivation for including symbol.h. But what you saw that I did is I actually removed that include, and I just simply replaced it with the forward declaration of the class. So it raises the question, when are you able to get away with the forward declaration? Why would you want to use the forward declaration, and when are you unable to use it? The reason why it's a nice thing to use, particularly, or I should say it primarily is of interest in header files, is that there's so many header files going around that you end up with kind of these circular includes where file A tries to include file B and file B tries to include file A. Inevitably you have something that's undeclared. And the forward declaration kind of removes those kind of circular dependencies with regards to header files. Source files in general, you don't frequently get away with the forward declaration because the source files generally are invoking behavior on that thing that you are trying to decide whether to include. For example, let me what am I looking at? So let me look at variable.cpp. So right here on this line, I'm invoking a member function on an object of type symbol. For that to compile, I actually have to have the entire header file for symbol included, because that has all that information in it. Okay, so that's the reason why I need to use a pound include, particularly in source files, but potentially in header files. Here, the only piece of information that the compiler needs to know is that symbol is a thing. Because set aside, shared pointers are still a little bit new to the eyes, but we can simply look at those shared pointers and say that is just a pointer to a symbol object. Okay? And the compiler doesn't need to know anything about symbol other than the fact that it's a thing that's out there. Right? Because regardless of what it is, whether it's a float, a double, a variable, an expression, a pointer to it is going to be the same size, just whatever the size of an address is for that particular machine. And as long as I don't try to do anything with a symbol other than say, hey, I need a pointer to one, then the compiler's happy. So to the extent you're getting tangled up in header files, that's probably the easiest way to sort it out is, one, obviously don't blindly include a bunch of stuff that you may not necessarily need, but if you know you need it, decide whether or not a forward declaration is sufficient. And the key thing usually is that you are only using that, you're only saying to the compiler some prototypes and that a pointer is involved. If that's all you're doing, the forward declaration works fabulous. Constantine?
All the thing that you need is just the name of that class, right?
No, it isn't correct for me to say the only thing I need is the name of the class, because, for instance, I could do, if I do this, the moment I say symbol S, now the compiler needs to know how much space that class takes up, because that then helps the compiler know how much space a variable takes up. So it isn't just the name of the class, but in particular the use case you normally find is that you only have a pointer to that type and you aren't doing anything with that pointer, right? That was what we saw on the other page, which we were actually doing something through that pointer. So at that point, all bets are off and you have to include the entire header file. Yeah?
And I assume that's because if you want to get a member of a class, then you need that information because that's only in the header file. There would be no way for the compiler to know.
Right, right. The moment you do anything with that type, that's generally when you're going to have to include. All right, so I wanted to pass that on. And the other thing is, I don't think I ever gave a formal treatment of it. There would have been mention of it in the write-up, but let me just say what's happening is that whenever you're returning something, I've got this surrounded in RET. And what that is that's a convenience function to really help us manage memory. First, a sidebar. By definition, the delete function can delete a null pointer without problems. So there's a tendency to have this kind of code. If evaluated constant does not equal null pointer, then go ahead and release it. Well, that's such a common thing to do that in the standard they made it so that if it is a null pointer, delete just silently, doesn't do anything. So you don't have to check to see if it's a null pointer. The reason this function exists is that there are a couple edge cases. It becomes a regular thing in later projects, but there are a couple edge cases in this project where evaluate is being called more than once. And when evaluate is called, let's ignore this delete. When evaluate is called, then what's happening here is a constant object is being allocated, And then the address of that constant object is being assigned to this internal variable. It's just an expression pointer. Or maybe it's a constant pointer. I guess we can look at it. Yeah, it's a constant pointer. And so what happens is if you evaluate more than once, then a new constant object is allocated and assigned to this variable, and then the old one goes away to the nether void, and it's a memory leak. Now, if you're very conscientious, on the other side, wherever it is you're calling the evaluate function, you can try and keep track of that original constant that you allocated and release it so that you don't have the leak. It's a big hassle. It's far easier to use this strategy, which is simply delete whatever was in that pointer before and now reassign it. So you can call expression all day long, and the previous constant you can call evaluate all day long, and the previous constant will be released before a new one is allocated and takes its place. So that's the reason for that. It's just for convenience, to make your life easier as far as maintaining memory integrity. I think those are the only specific things that I wanted to talk about. Any general questions you have at this point? Yes?
If you have if you're assigning a variable, or sorry, if you're assigning an array to a variable, where do you check?
In GPL?
Yes.
All right, so let me write. Okay, so what, I've got an array.
Right, and then you assign that array to another double.
Incorrectly, like that, or
Incorrectly, like out of bounds.
oh, so like -20?
21 or something. Or yeah. Where in the parser do you check for that comparison, I guess?
The time where it's checked is when your variable doesn't evaluate. So just like any other expression, when you say evaluate on a variable, it's going to give you a constant object. So if we use this legitimately for a moment, that when evaluate is called on this, and let's back up. Where in the grammar is evaluate called on this? So what we're doing here is we're doing a declaration. We're bringing a variable into existence, a variable x. And ARR sub 10 serves as the optional initializer. So it's in the variable declaration production in that first rule. And oops. Oh, I was there. And it's right here.
Right.
So that's where we're doing the evaluation. $4 in our case is ARR sub 10. That's where it's fine. So it's possible that it could be that. Let's go ahead and continue tracking that down. That's going to be in variable there. So it isn't going to be this one. That's just like saying int I equals x. It's going to be the second one, which is, so what do we have? Int, let me borrow that. So this is this portion right here.
And doesn't it split off the array index.
All right, so that's going to be $3, right?
Yeah.
All right, so let's, got some errors here. All right, right here. If it isn't an integer, complain. And then put a dummy variable in its place. Otherwise, we go ahead and throw it in there. So we don't note that we didn't evaluate it at that point, right? So it isn't. We aren't going to know it's a -20 until the evaluate function is called up in the variable declaration. And so when we look at variables evaluate, first always check to see if it's one of those dummies. And it is right. Right there. We get the index. We've already checked to see that it's an integer, so we're confident that it's an integer by the time we run this line of code. That'll put -20 as index, and then we simply ask the symbol, please give me yourself as a constant and give me the -20th value. And so as constant doesn't vomit up. Let me look at the write-up. Let me see. It looks like I don't explicitly mention it there. So right here, maybe I'll put an edit and add that. So what I would say is if the index is invalid, then simply return. Oh, well, it's done right. Okay, so there's where the error. Right, as constant, it's going to return null pointer. So let me look at symbol dot CPP as constant. So that's the check right there. So inside of variables evaluate, you get the symbol as a constant, providing the index, and then you check for if it's a null pointer. If it's a null pointer, variables evaluate function is going to report on it, and then just return. Note the behavior is line 28. It gives you the first element in that array. So I'll make a note of that in the write-up, that as constant index, if it's given an invalid index, that it will go ahead and just simply return null pointer.
And I forgot if you do have an invalid type, I guess, which errors do you want to recreate an integer constant as 0 versus?
For arrays?
No, like keyboard, for example. If you have an invalid type, you just report the error and then keep going. like, because if you divide by 0, you want to replace that constant with.
Right. So the situation is where you have something like 3 plus 8 mod 0 plus 9.
Yeah.
And the philosophy is that you want to put something in place of this failed operation so that evaluation of the rest of the expression can be done. And the reason for doing the rest of the expression is to be able to report on it, right? So if I have this here where I have 8 mod 0, 9 divided by 0, the compiler is serving me better if it reports on both errors rather than just the first error it comes across. So there has to be some sort of recovery for 8 mod 0, and that recovery is line 617, which is to return integer, basically put an integer constant 0 in that location. You jettison the idea of the modulus and just put a 0 there. And that ends up being a pretty good strategy because even if you have something like this, the nice thing about integers generally, is that they promote to the other types, right? An integer will promote to a double and it'll promote to a string. So if you have doubles or strings elsewhere in the expression, that doesn't cause any issues. What else?
What about catching invalid type? In the same action?
For like modulus or division?
Yeah.
Invalid type for the operands?
Yeah.
All right, so it's a little bit there are a number of ways that you can do it. What a lot of people do is the actual check for invalid types happens in that code that we moved up into a template. And the problem, as this comment says, is, let's go look at that template real quick. The problem is if there's an issue with an invalid type, then it's going to release the operands because it's going to put a 0 there, which is all fine and great. The problem with doing it down here is I'm unable to report on a divide by 0 if it releases that stuff, because then I can't look at it and say, hey, are you 0? So the strategy I took was to find out the type of the denominator, and if it's an integer and that integer is equal to 0, then I set a little flag and then I report on that flag. And the problem is that the error messages are such that it complains about type before it complains about divide by 0. All right, the situation we're looking at is something like Barney mod 0. And Barney's an invalid type, which the template will release both of those, and then I'd be unable to check if it's dividing by 0. So I need to kind of see if it's dividing by 0, then I do the type checking, and then I report on the division by 0. All right, so I'll go ahead and stop this recording, and as I did last time, what I'll do is I'll just dedicate the rest of the day to being tech support. Maybe we'll make it real where you got to call me and describe your code to me.